Okay, section 16.1. Of course, on the test, it won't tell you which sections they're from, so you're going to need to figure out how do you know when to do integration by parts versus how do I do u substitution. So here's my big hint to you. If it's just e to a number x in the problem, and you have a bunch of other stuff, just like this problem number 7 here, then it's going to be integration by parts. Du minus the integral of v du. Or if you have a natural log of x in the problem, and you have other stuff being multiplied to it instead of being divided by it, that's also going to be integration by parts. If the e is being raised to anything other than a number x to the 1, definitely not integration by parts. It would be a u substitution problem. Alright, so this is integration by parts problem. Anytime you have an e, that's going to equal your dv. So I need to choose a u and a dv. So my e is going to be the dv, and the dx always goes with that. Everything else in the problem is going to be the u. So then I have to find my du. I'll take the derivative of u and I get 2 dx. And then I have to integrate to find my v. When I integrate e to the 4x, I get 1/4 e to the 4x. I've got my 4 parts now, so I'm going to put it into my formula, uv minus the integral of v du. I'll substitute each of these in. So u is 2x plus 5. V is 1/4 e to the 4x minus the integral of v, which is 1/4 e to the 4x times du, which is 2 dx. So I can multiply this through, and I'll get 2x times 1/4 e to the 4x plus 5 times 1/4 e to 4x minus, simplify this over here, 1/4 times 2 is 1/2 e to the 4x dx. I'm going to multiply that together. 2 times 1/4 is 1/2 x e to the 4x plus 5/4 e to the 4x minus, if I pull the half out front, the integral of e to the 4x is going to be 1/4 e to the 4x. So I just integrated that, plus c. So this is going to be the same, this is going to be the same, this is going to be minus 1/8 e to the 4x plus c. And then I'll be able to combine these two terms, because both of those terms have just a number e to the 4x. So I will end up with 1/2 x e to the 4x. If I add 5/4 minus 1/8, and I can do that on my calculator over here. So I have 5/4 minus 1/8, and I'm math bracket, I get 9/8 e to the 4x plus c. All right, so this was e to just a number x. Sometimes that's u substitution, but usually it's integration by parts. This next one has a natural log of x in it. If there was a natural log of x in the numerator and then x in the denominator, it would be a u substitution problem, because for u substitution, the derivative of natural log of x is 1/x. So we have something in the denominator. Since there's nothing in the denominator, but there's a natural log in the problem, this is going to be integration by parts. So I'm going to choose my u and my dv. Anytime there's a natural log in the problem, it's always going to be your u. So dv is going to be everything else. the derivative of my u, I get du equals 1 over x dx. And I'm going to integrate to find my v. So I get 18x to the third divided by 3. So v is going to equal 6x cubed. So I have my four things, my u, du, dv, and v. I'm ready to do my integration by parts. I'm going to write down u, v, minus the integral of v du, and I'll replace it with stuff. So this will be the natural log of x times v, which is 6x cubed, minus the integral of 6x cubed, times du, which is 1 over x dx. This first part is finished. Here, I'm going to simplify it before I take the integral. So 1 over x times x cubed, that'll cancel into that twice, which makes this 6x squared dx. And so this is going to stay the same. I'm going to integrate now, and I get 6x to the third divided by 3 plus c. And so I end up with the natural log of x times 6x cubed minus 2x cubed plus c. Evaluating a definite integral. If your limits of integration are not both numbers, you have to do this by hand. So we integrate. I get 3x to the 1 over 1 plus 8x squared over 2. And I'm going to evaluate this from -4 to a. I'm going to simplify it first. So this will be 3x plus 4x squared, and I'm going to evaluate this from -4 to a. The way you evaluate it, you always put the larger number in first. The larger number is the one on top. So I get 3a plus 4a squared, and then you subtract what you get when you put the number in on the bottom. So minus 3 times -4 plus 4 times -4 squared. And so I'm going to have 3a plus 4a squared minus 3 times -4 is -12, and this will be 4 plus 4 times 16. So I have 3a plus 4a squared minus -12 plus 64 is 52. So that's my answer. Sometimes we usually write the quadratic term in front. You don't have to. It's just a common thing to do. So that's fundamental theorem of calculus, finding the definite integral by hand. Number 10, sketch an accurate graph shading the area, set up the integrals, and find the area between this equation and the x-axis on the interval from 0 to 1.2. So the first thing I'm going to do is graph this. I'm going to go to my y equals screen, and I'm going to graph it. X to the fourth minus 4x cubed plus 2x. And zoom 6, just my standard window. Alright, so that's kind of small in there. And then I can't see the bottom of the graph either. What am I doing this from? I'm doing this from 0 to 1.2. Alright, so I'm going to kind of draw this. So I'm going to zoom in on this. I'm going to zoom in on that little part right there. I'm going to zoom box. So my cursor is on the origin. I'm going to take the corner, put the cursor in the corner of the box I want to look at, and hit enter. and then I'm going to go to the right and down and draw the box that I want to look at and hit enter. Okay, so my graph is doing something like this, and it has a really low part and it comes back up. But this x-intercept way over here is way beyond our domain. It's just running from 0 to 1.2. So 0 starts at the origin right there. So 1.2, which is about right here on the graph. So I'm going to say about right there, 1.2. So I'm looking for that little area. So I need to know what that x-intercept is. This one right here. I'm going to go to second trace, choice number 2. I'm already on the left side, so I'll hit enter. Then I'm going to move my cursor over to the right side and hit enter, and then enter for my guess. And it says round to 3 decimal places everywhere, so that is going to be 0.789. So this is the area that I'm looking for. Setting up the integral, I'm going to need to integrate from 0 to 0.789, my function that I have graphed in y1, and that's above the x-axis, so that's a positive number. Plus, I'm going to integrate from 0.789 to 1.2, and since that's below the x-axis, I want to take the absolute value of that number. Then I'll go back to my home screen and pull up math number 9. This is the old operating system, so I have to type it in order. For those who have the new operating system, it's pretty self-explanatory where you type it in. The old one, you got to type in the function, comma, x, comma, the lower bound, comma, the upper bound. Since my function is in y1, I'm just going to pull up y1. I can do that by going to bars, then y bars, then function, and I'll see y1. So bars, y bars, function, y1, comma, x from 0 to 0.789, and I get 0.296. Plus, I'm going to take the absolute value of this next one. I'm just going to hit second enter, pulls up the last thing I did, and it is going to be from 0.789 to 1.2. So the absolute value of negative 0.432, and I'll get 0.296 plus 0.432, and that gives me 0.728 for that answer. That was the area between the curve and the x-axis. The management of an oil company estimates that oil will be pumped out of the ground from a particular field at a rate, so they're giving us a rate, where RFT is the rate of production in thousands of barrels per year. T is the number of years after pumping begins. Approximately how many, so they gave us a rate and they're wanting to know how many. That means we're going to be integrating. How many barrels of oil will the field produce during the first 5 years? And it's in years, so we're just going to go from 0 to 5. So I'm going to integrate my function here from 0 to 5. And I can just use my function integrate on my calculator. I'll show the new operating system one for this one. So I'm going to go math number 9. From 0 to 5. If you have a fraction here, you could just do alpha y equals. Choice number 1 is numerator over denominator, and it will automatically make this happen. Alright, so in the numerator I'm going to have 120x, and denominator I have x squared plus 1, and I'm integrating with respect to x. And something went wrong. What did I did the typical. I forgot the plus 3 right there. So I'm going to hit second enter, and I'm going to go back inside my parentheses, plus 3. Alright, let's try that. Alright, so we get 210.485793. I'm just writing it all out because it had said earlier that this was in thousands of barrels per year. So I'm going to multiply that by 1,000, and when I do that, it moves my decimal place over 3 times. So I'm going to have 210,486 barrels. Okay, sketch a graph, set up the integrals, find the area between these two curves on an interval. So I'm going to graph this real quick. And I have, in y1, I'm going to put x cubed minus 3x plus 2. And the other one, I'm going to put 1.8x minus 1. I'm just going to zoom 6, standard window. Okay, and then I'm looking specifically on the interval from 0 to 2. So that's really small, congested area right there. So I'm going to zoom a box around what I need to see. I'm going to go to zoom. Choice number 1 is box. It's blinking at the cursor's blinking at the origin. So I'm going to go up and hit enter where I want the corner of my box to be right there. And then I'll go over to the right and down to draw my box. Hit enter and your box becomes your whole screen. And so I've got this one going this way, and then I have this line kind of going that way. And if you forget which is which, just hit trace, and you see which one your cursor is on right there. At the top, it tells you which equation that is. So this blue one is my y1, and the red one, if you hit the up and down arrow, it'll toggle to the other one. It's my y2. And I'm going to be going from 0, which is way over here on this side, so 0 is about right there, to 2. So I'm going to find what these 2 points of intersection are. Second trace, number 5, enter, enter, enter. I don't care which one it finds first. So it finds that one first. All I care about is the x value. That's 1.759, which is to the left of 2. So that means 2 is going to be over here somewhere. So I got a little area going on right there. Second trace, number 5. Enter, enter, and I have to change my guess so that I get the other point of intersection. And that is going to be 0.695. So I'm looking for this area, and then that last little area. So I will be integrating from 0 to 0.695. For that little section, y1 is on top, y2 is on bottom. Remember, you can tell by the top of the page, and if you just start drawing an arrow down, the first one you come to is the one on top. So it's going to be y1 minus y2 for that one. And then the integral from 0.695 to 1.759. For that part, y2 is on top. So I'll do y2 minus y1. Then I'm going to integrate from 1.759 to 2. And for that little area, y1 is on top, minus y2. So back on your home screen, you can go to math, number 9. I'm going to go to vars, y-vars, function y1, minus vars, y-vars, function y2, comma x, from 0 to 0.695. And I get 0.984. And then for the next one, I'll do math 9, vars, y-vars, function y2, minus vars, y-vars, function y1, comma x, comma 0.695, comma to 1.759. And I get 0.74. And the last one, math 9, vars, y-vars, function y1, minus vars, y-vars, function y2, comma x, comma, from 1.759 to 2. And I get 0.155. If I add those all together, I'll get 1.879. Okay, same idea here. I'm going to graph my two functions. I'll do this one on my new operating system, just so people can see that one also. So I'm going to graph e to the x minus 2. And then I'm going to graph the natural log of x plus 6. And I'm just going to zoom 6. Now this one just says find the area bounded by. It doesn't give any interval like the last one did. So we're just looking for the bounded between the two equations, which is going to happen right in here. So I need to find what that intersection is and what that intersection is. And all I care about are the x values. Then when I go to integrate, I'll have my limits of integration. If you forget which is which, hit trace, and it'll start tracing on one of them. And you can look at the top of the page and see which one that is. So my y1 is on the bottom, my y2 is on top. So this will be y2 minus y1. Finding my points of intersection, I'm going to go to second trace, number 5, enter, enter, enter. And that one on the left is at 1.386. Then second trace, number 5, enter, enter, and I have to change my guess. Went a little too far, I went off the function there. There we go. Enter. And it is at negative 5.864. So I'm going to integrate from negative 5.864 to 1.386. Back on my home screen, I'm going to go to math 9 from negative 5.684 up to 1.386. And vars, y-vars, function y2. Minus vars, y-vars, function y1. And this is all with respect to x. Hit enter. And I get 18 point, oh wait, I typed that in wrong. Right there. So I typed in 5.684. I should have typed in 5.864. So I'm going to hit second enter and fix that mistake. Only reason I know that is because I have my answers already written on my paper here. So negative 5.864. There we go. So I get 18.294 as my answer for that one.